Hello, Fraction Camp, and another fraction routine using pattern blocks. This one is called multiples of unit fractions, ideal for third and fourth grade students and teachers. Also really critical for fifth grade teachers to support this. Okay, so we've already talked about varying the whole, and here I have a whole defined as one yellow hexagon. Here I have a whole defined as a yellow hexagon plus the brown, what's that called? I forgot, trapezoid. Yes, brown trapezoid. And then one whole defined as the yellow hexagon plus the green equilateral triangle. Okay, so if that's the case, I'm changing what the whole can be defined as. I want to know what value is that. So that's challenging. So first what I have to do is define, what value is this then? I already know that that's 1/6. I've done it before. Students might know, but I still want their reasoning. And so if that's 1/6, then what value is this unknown piece? Well, notice that the red piece can fit 3 of the green. The red trapezoid can fit 3 of the green equilateral triangles. So that's 4. So that means that's actually equal to 4/6 because, and then my reasoning is because 4 times, or yeah, how do I want to say this? 4 times 1/6 size pieces. No, that's not how I want to say it for kids. 4 1/6 size pieces are 4/6. I think that's how I want to say it. I'm going to work on that a little bit. Okay, so that's what you want to do. Okay, so here I want to know what's the value of this trapezoid. So again, I'm going to define a unit fraction. This is equal to 1/5. You can convince yourself of that by comparing the browns to this whole. There's 4 of them in the yellow equilateral triangle, the yellow hexagon, and 1 more, so that makes 5. So that's 1/5. And you want kids to actually do this to compare the browns to the red. And what do you end up with? 2 browns. So this has a value of 2/5. And then I want to say because 2 pieces with a value of 1/5 each makes 2/5. That's how you want them to think. And the same thing goes here. First, I'll establish a unit fraction. This is equal to, remember there's 6 here plus 1 extra, so that's 1/7. And my reasoning would be because 7 equal pieces are equivalent to a whole. Remember there's 3 of those triangles here. I hope you see it by drawing on there. 3 triangles. So this has a value of 3/7. ... means give me your reasoning. Okay, I need to hear that reasoning. Okay, so what are the challenges here? By the way, you want to do this multiple times. Let me erase the block for those of you who get freaked out by me drawing on blocks. Okay, so what are things that students will struggle with here? Teacher, why is the green one 1/6 here and why is it 1/7 here? You're going to need to constantly reinforce the idea that the fractional value of the block is only defined in relation to the whole. Why is it 1/6 here? Because that's the whole. Why is it 1/7 here? Because the whole is different. It has 7 green blocks, whereas this one only has 6 green blocks. That's what you want to do. Also, why does the red trapezoid here have a fractional value of 3/7, but here it has a fractional value of 2/5? Why is that? Like, shouldn't it be the same? And the answer is no. Fractional values are only defined in relation to or compared to the whole. Here I'm comparing it to this whole. Here I'm comparing it to this whole. And that changes the fractional value.